we want to wind this up with two variation problems. The first one will be a direct variation problem, and the second one an inverse variation problem. If we say y varies directly with x, what that means is that y is equal to some constant k times x. So that first sentence in the problem here gives me this general variation equation. The first part of the second sentence is going to allow me to evaluate k. When we say if y is 10 when x is 2, okay, that tells us that y is 10 when x is 2. So 10 is equal to k times 2. That tells me that k is equal to 5. So I take my k equal 5 now, substitute it back into my general variation equation, and I end up with a specific variation equation of y is equal to 5 times x. So this part right here that allows me to evaluate k, that comes from this first phrase in the second sentence where it says if y is 10 when x is 2. So I put 10 in for y, 2 in for x, and I'm able to evaluate k. Now I can answer the question where it says find y when x is equal to 6. So I want to find y when x is equal to 6, so y must be equal to 5 times 6, which is 30. So we would say if y varies directly with x and y is 10 when x is 2, then y is going to be equal to 30 when x is equal to 6. So you see it's a step-by-step process right here. This is a general direct variation statement where we say y varies directly with x. Let's look at an inverse variation problem. Y varies inversely with the square of x. Now what that first sentence tells us, y varies inversely with the square of x, is that y is equal to k over x squared. That means that y varies inversely with the square of x. Now I want to evaluate k, and I'll use this first part of the second sentence where we say if y is 45 when x is 3, okay, y is 45, when x is equal to 3, 3 squared is 9, so I get k is equal to 45 times 9, which should be 405. So that allows me to write a specific variation statement as y is equal to 405 divided by x squared. Now, let's find y when x is equal to 5. So I'll substitute in 5 for x, and I get y is equal to 405 divided by 25. And let's see, that will be, let's see, I can reduce this to lowest terms, I guess, by dividing numerator and denominator by 5. Divide this by 5, I get 81. Divide this by 5, and I get 5. So y is equal to 81/5. It doesn't come out to be a nice number, but it is the correct answer if y varies inversely with the square of x, and y is 45 when x is 3, then y is going to be 81/5 when x is equal to 5. So there's two problems, one a direct variation problem and the other an inverse variation problem.